Hi all, this is Priyadashni working as an assistant professor in the Department of Artificial Intelligence and Data Science. In the previous lecture, we were discussing about the introduction to deep learning. In this lecture, we are going to see about the mathematics involved in deep learning. So we all know deep learning, it is a new AI powered technology that helps the models to learn the complex features from a humongous or the huge amount of data without any manual feature engineering. So you have to understand that when you know deep learning, it creates model to or it automates the model to learn a complex feature from the huge amount of data. But when you use deep learning with mathematics, you can train or you can model the machine such that you can debug, optimize and innovate. So understand mathematics is very important in deep learning so as it helps to create an intuition, control and AI powered system. Let's understand in brief why do we need to study math before deep learning. So as I already told you, math forms the basic of deep learning and also it gives the intuition and control of these machines. Deep learning as you take, deep learning is an inspiration of a neural network. So it uses artificial neural network that mimics actually like a human brain. It acts like a blueprint. So neural networks are not only the black boxes of your deep learning model, but also it acts like a mathematical machine. So why do we call it as blueprint is without this neural networks. So in neural networks, we all know that each neuron helps to learn something new. So each layer helps us to learn something new, but that is done by a neuron. So each learning step follows an equation. That is why we call the neural networks as the blueprint. So this neural networks acts by involving mathematics. So without math, you cannot design a complex architecture. You do not understand why the network or the model fails or you cannot tune the performance. So to all this, we have to have a deeper knowledge in mathematics to understand deep learning models. So when you take deep learning, the deep learning stands basically on the four mathematical pillars. The first one is linear algebra, statistics, probability, and finally it is calculus. So you all know mathematics is very important in deep learning too in order to make the model perform better. So the first one, linear algebra, statistics, probability and calculus are the mathematical pillars. And then we all know that each of these pillars has a unique thing or a unique identification that helps the deep learning model to perform better. But the most and the simplest thing is the linear algebra. So linear algebra is very important because this is the language that the neuron speaks. As I told you previously, why algebra is important in deep learning. We all know that the algebra is the main thing or the language that the neural network speaks. Why it is important? Because the neural networks process the complex data as vectors and matrices. So when you speak about weights, it is a vector. When you speak about inputs, it is a vector again. What about activation? It is a matrix. So each and every forward pass in the layers of deep network forms a matrix multiplication. So if you understand matrix multiplication only, you can understand how the data is being processed. So linear algebra is very important to understand how the information is being processed by the deep learning model in several layers. The first thing in linear algebra is the scalars. So scalars are the smallest building block in linear algebra. So we have to understand what is a scalar. So a scalar is a single numerical value. For example, 20. So scalar is just a numerical value in linear algebra. So it has only the magnitude, does not indicate the direction. It is the simplest unit in mathematics too. So the applications where you use scalars are when you have to describe what is a loss value, what is a bias, or what is a loss function, or the learning rate of the model, we have to use scalars. So scalars are the simplest building block, but it is not only small, it controls how fast your model works. Next we have vectors. So as we all know, vector is an ordered list of numbers, that is a one-dimensional data. It has both magnitude and direction. So I have given examples here. So this is about vector, which is a one-dimensional array of numbers. So when you speak about inputs, they are vectors. Activations are vectors. Word embeddings are also vectors. So in general, vectors help us to represent the information. Okay, the vectors represent the information more meaningfully and also even compact. So the next one is matrices. Matrix is a two-dimensional array of numbers arranged in rows and columns. So what is its role in deep learning? When you speak about matrices, when you say wait between layers, then you have to use matrix for storing. When you have to represent a grayscale image, then you have to use matrix. And also when even it is used in forward propagation, that is forward pass in neural networks, you have to definitely know about matrix multiplication. In short, no matrices, no neural networks. So the final one is about your tensors. Tensors is a multi-dimensional array. So when it is about 2D, then you have to use for 3D or 4D, you have to use tensors. The examples might include your color image or your width channels. Everything comes under that uses tensors. So the role is it is used to represent all the data representation in your DL frameworks like PyTorch, TensorFlow, etc. It helps to handle complex images, videos, etc. It is also a multi-channel data. So when it is 0D, it is a scalar. 1D, it is a vector. If it is 2D, it is matrix. More than 3D, it is a tensor. Thank you.